this video, we'll look at a distance, rate, time problem that uses rational equations to solve. Specifically, our problem is going to be a bike problem where part of a trip is done at one speed and the other part of the trip is done at a different speed. This is a pretty common type of problem. It could be bike riding or hiking or anything. It could be one part of the trip is in a car and the next part is on a bike. But when we have more than one portion of a trip and we're trying to find something about the distance or the rate or the time, we could use the same method. So let's look at this problem. Ella Lou rode the first 24-mile portion of the Katy Trail at a constant speed. For the next 20-mile portion, she reduced her speed by 2 miles an hour. She must have been getting tired after going 24 miles on the Katy Trail. So each portion of the trip took the same amount of time. Find Ella's speed for each of the two portions of the trip. I'm going to get a better understanding of this problem by putting the information into a chart. You can see that I've started that work here already. I've created a chart, a distance, rate, and time chart, and I've labeled the rows as the first part of the trip and the second part of the trip. The first distance was 24, the second was 20. The first distance, I'm going to let that be our variable. I'm going to let x equal the initial speed. And then when we get to that second part of the trip and Ella is losing some of her energy, the speed drops down to what it was minus 2 because we reduced the speed by 2 miles an hour. What I know about this distance, rate, and time, you're probably pretty familiar with distance equals rate times time. What you might not have done as often is use the same formula to solve for time. Because you see, if I divide both sides by rate, that gives me that time is equal to distance divided by rate. Or you could see if I divided both sides by the time, I'd get that rate is distance divided by time. So just like you know, distance equals rate times time, you could then use that to get these other two formulas. The one we're going to use this time is that time is distance. So in this case, 24 miles divided by the rate, x miles an hour, and the distance 20 divided by the rate of x minus 2 gives us the time of the second part of the trip. The next thing we need to understand about this problem is that we're given more information. We're given that each portion took the same amount of time. So what I can do now is I can write a proportion with 24 over x, that's our first time, equal to 20 over x minus 2, our second time. Now because this is a proportion, I can solve it by cross multiplying. And when I cross multiply, I get 24 times the quantity of x minus 2 equals 20 times x. If you need to pause the video and get your own review of cross multiplying, you might benefit from that if you're not sure how I just made this second step. Next, I'm going to distribute the 24 because I have a linear equation to solve. So 24 times x minus 24 times 2. I could use a calculator, but it's just as easy to multiply 24 times 2 without that calculator. Equals 20x. To solve this linear equation, I'm going to move all the x's to one side. So I'm going to subtract 20 from both sides. Or rather, I should say subtract 20x from both sides. And what I get, here, let me continue up here at the top. 24x minus 20x is 4x. 4x minus 48 equals 0. I could add 48 to both sides, and that gives me that 4x equals 48. Now to solve, I just divide both sides by 4. 48 divided by 4 is 12. So I get that x equals 12 miles per hour. The first part of Ella's trip the initial speed was 12 miles per hour. Then she reduced it to 12 minus 2, or 10 miles per hour. You know, an important part of solving problems is checking, going back and checking that you've answered the question. Let's check that we've done that. Find Ella's speed for each of the two portions of the trip. Yes, we found the speed for the first portion, 12 miles an hour, and for the second portion, 10 miles per hour. So it looks like we have successfully solved this question. I hope you found this short video helpful. If you'd like to see another distance, rate, and time problem, there's another video for wind speed type problems and other rational equation problems such as a work rate problem.